Welcome back to Brew Fix, where coffee meets craftsmanship. And today we're tackling a concept that sounds logical on the surface, but falls apart under real science. Even if you could grind perfectly uniform coffee particles, extraction would still be uneven, because particle size is only one variable in a much more complex system governed by chemistry, cellular structure, fluid dynamics, and heat transfer. We tend to blame uneven extraction entirely on particle size distribution, assuming that if every fragment were identical, water would dissolve solubles evenly and produce a perfectly balanced shot. But even two particles of identical size can behave completely differently during extraction due to differences in internal microstructure, roast development, density, and surface fractures created during grinding. Coffee is not a homogeneous material. It is a cellular matrix composed of cell walls, vacuoles, trapped gases, lipids, and soluble compounds distributed unevenly throughout the bean. And when a burr fractures a roasted bean, it doesn't create identical spheres, but irregular shards with different surface exposures, internal crack patterns, and structural weaknesses, meaning one particle might have more open cell walls and greater solvent access, while another of the same size remains structurally denser and slower to release solubles. Beyond structure, solubility itself is time-dependent and compound-specific. Acids dissolve rapidly, simple sugars require slightly longer contact, and complex bitter phenols extract later in the timeline. So even if particles were uniform, the rate at which water contacts and penetrates them would vary depending on local flow velocity, temperature gradients, and micropressure differences within the puck. And here's where fluid mechanics takes over. Espresso extraction is not immersion. It is forced percolation through a porous medium, which means water does not surround every particle equally but travels along preferential pathways determined by local resistance, pore geometry, and pressure gradients. So even with identical particles, some regions of the puck will experience higher flow rates, while others experience slower diffusion-dominated extraction, leading to localized over and under extraction simultaneously. Heat distribution further complicates the picture because temperature slightly decreases as water travels through the puck, altering dissolution kinetics across depth layers. And since solubility increases with temperature, particles closer to the top of the puck may extract differently from those deeper in the bed. Additionally, as extraction progresses, the puck itself changes, solubles dissolve, structural integrity weakens, and fines migrate, altering permeability mid-shot, which shifts flow patterns dynamically, meaning extraction conditions are not static but continuously evolving. Even if particle size distribution were theoretically perfect, you would still be dealing with non-uniform pressure fields, heterogeneous internal chemistry, and time-dependent structural deformation, all of which guarantee uneven extraction at the microscopic level. This is why extraction yield as a single percentage can be misleading, because it represents an average of thousands of particles behaving differently rather than proof of uniform dissolution. The real goal of great espresso is not achieving perfect evenness, which physics makes impossible, but minimizing extremes by narrowing particle distribution, stabilizing flow, controlling temperature, and maintaining grinder alignment so that variability stays within a delicious range rather than a chaotic one. Once you understand that uniform particles do not guarantee uniform extraction, you stop chasing the myth of perfection and start managing the system intelligently, focusing on grinder condition, puck preparation, machine stability, and water chemistry as parts of an interconnected structure rather than isolated fixes. Espresso is not about eliminating variability, but controlling it. And that shift in mindset, from searching for a magic uniform grind to understanding extraction as a dynamic, evolving system, is exactly what separates frustration from mastery, and exactly what we teach here at BrewFix, because espresso doesn't fail due to one variable. It becomes unstable when we ignore how all of them interact under pressure. Wrench BrewFix, keeping your coffee machines running and your mornings caffeinated.